This is it, the last section for chapter 1. We're going to be kind of building on our angle lessons from the day before. And we're going to talk about how many different types of angles? 5? 5. And these are really going to be kind of using angle relationships, combine that with algebra to set up and solve equations. But make sure you know how to use each of these different angle relationships. The first one is complementary angles. These are two angles that add to 90 degrees. Remember, 90 degrees is a right angle, so these guys are going to be making an L when you combine them. Keyword, when you combine them. So you might have something like this. You might have a 90 in the corner and just say, oh yeah, those guys are going to be complementary because they add to 90 degrees. So we would say angle ABD, D, and angle DBC are complementary. So complementary adds to 90. Supplementary angles are similar, but these guys add to 180. So these are two angles that add to 180 degrees. Boom. And if you remember from yesterday, that is a straight angle. So these are two angles that combine to form a straight line. Looks like this. And the whole deal is 180 degrees. So we could say W, angle W, X, Y, and angle Y, X, Z are supplementary. And remember, that means it adds to 180. So if I was to do an algebra problem with this, I would take these two measures, say this piece plus that piece equals 180. And if you want a little quick trick to remember how many degrees complementary is and how many degrees supplementary is, if you draw a C, watch this, if you draw a C, and then you go straight down, you got a 90. So C can turn into a 90, not bad. And watch what happens with supplementary. We take an S, watch this, connect the ends. What? Math magic, 180. So again, complementary angles add to 90, supplementary angles add to 180. Enough magic tricks. Let's go to the next one. Next one, not last one. Adjacent angles. These guys don't really have a special relationship. Adjacent angles. They're just angles that share a side and a vertex. Okay, they share a side and a vertex. To give you an example of this, something like this. You might be like, why, Mr. Maxson? We just saw that. That's like, those are complementary angles. Good eye. It is complementary angles, and complementary angles, as well as supplementary, are a form of adjacent angles. Or they can be. And the reason is because they share this side. You'll notice ABC is adjacent. Adjacent means next to. So ABC is next to CBD. Those angles are exactly next to each other. They share a side, that side in the middle. So we could say they are adjacent angles. Why that even is a thing that we care about is because they're right next to each other. We know part plus part equals whole. So it's adjacent angles set up for the angle addition situations. So we could say angle ABC and angle CBD are adjacent. Bam. Alright, 2 more to go. Whew! We are getting there. Oh man, I can see the end of the notes for chapter 1. Man, I know what you're thinking. You're thinking, we just started. I know, time flies when you're having fun. And you are definitely having fun right now. We'd be having more fun if we were in class, but again, we'll do the best we can. Linear pair. These are 2 angles that form a straight line. Okay. And you might be like, well, Mr. Michelson, that looks a lot like a supplementary angle. Yeah, you'd be correct. Ooh, this is another way to name an angle with an inside letter or variable. Man, I should have said that back in the angles lesson. Oh well. Angles 1 and angle 2 are a linear pair. Remember, linear means makes a line 180 degrees. Now, one difference between a linear pair and supplementary angles are a linear pair must form a straight line. The angles must be connected. Supplementary angles technically do not have to be right next to each other. So just be aware of that. Linear pair, they must be adjacent. Supplementary, they can be adjacent, but they don't have to be. It just has to be anything that adds up to 180. Last but not least, and probably, yeah, this is definitely going to be the relationship you use most. Vertical angles. So with vertical angles, these are 2 angles directly across from each other. And they're made up of the same lines. And vertical angles are congruent. Okay. I'm going to give you some examples of this guy. So in this particular situation, 1 and 3 are right across from each other, and 2 and 4 are right across from each other. Those guys are vertical. Remember, that means they're also going to be congruent. So if I was solving this, if I knew angle 4 was, I don't know, 95 degrees, I would know angle 2 is also 95 degrees. So I'd say angle 1 and angle 3 are vertical, and angle 2, angle 4 are vertical. Now, another example, just so you see something that might not be vertical. Check this out. In this situation, what are your vertical angles? Well, you might say, well, 1 and 3 are across from each other. That's true. 1 and 3 are across from each other, but are they made up of the same lines? Angle 1 is made up of these lines. Is angle 3? No, no, no. Angle 3 shares this line, but then it's got this little middle guy here. So angle 1 and 3 are not vertical. 2 and 5? See how they're made up of the same lines? Yeah. Angle 2 and angle 5 are vertical. You can also kind of like eyeball these guys a bit, as in which ones look congruent. 2 and 5 look about the same. 1 and 3, well, 1 is clearly bigger than 3. 1 looks like an obtuse angle. 3 looks like acute. So again, just be aware that for something to be vertical, it has to be made up of the same lines. Alright, so we're done with notes for chapter 1. Woo! I'll see you guys on the examples for this lesson. Hope you guys have a good day. Bye-bye.